NASA didn't see this coming. On December 3rd, during a quiet observing window, a high-resolution infrared pass returned a shape that shouldn't exist around 3I Atlas, a faint arc. A circular ring, symmetrical, coherent, steady, as if traced with a compass in deep vacuum. This isn't a tail. This isn't debris. This is something else entirely, and it changes everything. At first, the way a single strange data point can tilt an entire story. If you've been following 3I Atlas through our solar system, you already know it isn't a typical interstellar visitor. Its trajectory is too clean. Its behavior is too calm. But with a ring-shaped anomaly rising out of the data, we're forced into a new question, one that reaches beyond composition or speed. How does a fast-moving comet from another star system wear a perfect ring? The answer isn't buried in theory. It's in what we're actually seeing, pixel by pixel, frame by frame, and we're going to walk through it together. It began, like so much in modern astronomy, with a dataset nobody expected to matter, December 3rd. Just after 0400 UTC, a thermal oddity surfaced in a frame from NASA's Goldstone Deep Space Complex. The scan was a scheduled long-wave infrared pass, tuned not for pretty pictures, but for mapping how heat disperses across the coma of 3I Atlas, an invisible weather report of temperature and drift. Nothing unusual was expected. The team anticipated a diffuse thermal plume, the classic uneven warmth of outgassing, like every active comet before it. But that's not what appeared. The anomaly was flagged by software first. Not a human eye. An automated contrast tool outlined a closed loop, faint, yet perfectly circular, centered around the nucleus, with no knots, no gaps, no ragged edge. The internal readout tagged it as a radial coherence anomaly, a label reserved for patterns too uniform to survive turbulent environments like comet tails or fragmentation clouds. A ring. At first, the scientists overseeing the pass assumed an artifact, the kind that sneaks in when antennas blink or algorithms overreach. Rings don't form around comets, certainly not around fast-moving interstellar objects with no known satellites, debris clouds, or collision remnants. So the first internal memo noted a visual inconsistency and recommended rerunning the scan through denoising filters. No urgency. No escalation. But the filters didn't erase the ring. They sharpened it, tightening the circle as though it were hugging a single, deliberate isotherm. That same morning, the anomaly was confirmed not only by Goldstone's thermal imaging, but by a second independent source, the infrared telescope facility on Mauna Kea, Hawaii. Different angle, different instrument, same shape. The odds of two independent systems producing the same false ring were near zero, and anomalies are supposed to smear with distance, not repeat with grace. Still, the response stayed muted. Early reports moved through low-priority channels, flagged as non-urgent curiosity, and quietly parked for review. But not everyone accepted that framing. One junior JPL astrophysicist, trained in planetary ring dynamics, noticed what others missed. The ring wasn't merely present, it was phase-locked, like a gyroscope finding its groove and refusing to drift. Its position relative to the object's spin axis stayed consistent across multiple frames. In other words, it wasn't drifting like loose debris, it was holding orientation. That changed everything. When this detail reached a closed-door data review later that day, the tone in the room shifted. Suddenly, what had been dismissed as sensor trickery became an unresolved structure, a ring-shaped thermal halo rotating with the object. The analysis was still raw, but it raised hard questions. What natural process could produce a symmetric feature this stable? Without any of the prerequisites for rings, where was the dust? Where was the breakup event? Why wasn't it visible optically? The meeting ended with no official conclusion, only a consensus to withhold comment, to speak softly and wait. The data would be internally circulated to test whether the feature persisted in upcoming passes, but even that decision carried unease, because the real issue wasn't validation, it was implication. Rings in nature are fragile. They usually require parent bodies with meaningful gravity, like Saturn or Uranus, or at least shepherd moons to keep particles in line. But 3I Atlas was barely large enough to sustain a coma, and it had no known satellites, no tiny shepherds, no companion rubble, nothing obvious to keep a belt of material disciplined. The physics didn't add up, and that is what made the discovery quietly terrifying. The final internal memo of the day used a phrase no one expected to see attached to a comet unexplained coherent rotational ring. It wasn't published. It wasn't leaked. It was locked behind clearance-level access. And from that moment, the mood around 3I Atlas changed. This wasn't just an interstellar object anymore. It felt like something else. And the people tracking it were no longer simply observing a comet, they were watching a structure. Once the infrared anomaly was logged, the next logical step was triangulation. Optical telescopes couldn't see the ring, not through that thin, ordinary coma. The coma of 3I Atlas remained visually unremarkable, faint, pale, unresolved. But radar, with its ability to bounce signals off solid surfaces and return echoes with sub-millimeter precision, offered something different geometry. 2 days after the thermal ring was flagged, a coordinated radar sweep ran through the deep space network. Using the Canberra and Madrid stations in tandem, the goal was simple, at least on paper: map rotational wobble, and see whether surface irregularities could explain the infrared symmetry. What came back wasn't an explanation. It was a pattern. The radar returns looked so strange, the system initially flagged them as a corrupted ping loop. In every sweep, a faint secondary echo returned, offset from the nucleus echo by a consistent radial distance. This wasn't atmospheric interference. It wasn't a trailing debris cloud. It was a ringed return, an annular echo, like a second outline hovering at a fixed radius. Something was deflecting radar energy around the nucleus in a fixed circular profile, repeating every rotation, every angle, every pass. The ring wasn't merely present. It was coherent. Analysts tried modeling the echoes using known cometary shapes. Maybe it was a dense coma band, maybe a field of debris orbiting the core, grains caught in a slow carousel, but no model fit. The echoes were too clean, too sharp. A natural dust halo would look fuzzy, scattered, diffuse. This return had edges. One radar technician said it behaved like a toroidal frame. Borrowing the closest analogy they knew, the donut-like fields in tokamak reactors, engineered to hold plasma. It wasn't meant literally, only as a metaphor for what the data implied. Because humans reach for familiar shapes when the universe offers new ones. To be clear, this didn't prove the ring was metal or artificial. There was no reflection spike, no beam doubling. The signal didn't saturate the way solid composites would, but it did return a consistent contour, wide, hollow, equidistant from the center, as if outlining an invisible belt. The team began calling it the shadow band, not because it was dark, but because it was quiet. A soft missing note in the echo. The ring absorbed just enough radar energy to soften the return, creating a measurable dip, a donut-shaped null zone that appeared again and again, regardless of where the beam originated. At this stage, silence became protocol. No outside observatories were briefed. No public logs were released. Internally, though, debate ignited quiet voices, clipped sentences, and long looks at the screens. Was this a shell of dust gravitationally bound to the comet? Unlikely. 3I Atlas was moving too fast, and its mass appeared too low. Could it be a magnetic dust trap? The object had shown no strong signs of electromagnetic interaction. And then someone asked the question that changed the air in the room, the one that makes engineers sit up straighter. What if the radar isn't bouncing off dust, but structure? That word structure shifted everything. It didn't declare artificiality, but it introduced intention. A ring suggests design. And in space, design usually implies one of two things: formation or deployment. If the ring formed naturally, it should be irregular. If it was deployed, Then what were we truly looking at? The final cross-check came from an unexpected corner amateur radar pings from a decommissioned dish in Eastern Europe. Lower resolution, yes, but their data showed the same radial band. Blurred yet unmistakable. That meant it wasn't an equipment error. It wasn't calibration noise. It was real. Whatever circled 3I, Atlas wasn't temporary. It wasn't chaos. It was stable, persistent, and responding to high-frequency radar in a way nothing natural should. From that moment on, the tracking team adopted a new internal tag, closed orbital anomaly. Repeating, it would take weeks for the implications to surface. But the ring had spoken, and radar had listened. Patient as a metronome in the dark. Rings require mass. That's the rule. Whether you're looking at Saturn's bright bands or the faint narrow loops around Chariklo and Haumea, the mechanics are the same. A central body massive enough to anchor material in stable orbit must provide the gravitational well. Without that, particles drift. A ring disperses. Orbital physics simple. Universal, 3I Atlas doesn't fit the equation. Estimates place it somewhere between a few hundred meters and a few kilometers wide, barely enough to form a coma. Let alone sustain a ring. No known satellites. No measurable magnetic field. No shepherd moons. And yet, as of December 3rd, it is encircled by what appears to be a structured, symmetrical ring. That single fact sent scientists scrambling after the radar confirmations and infrared detections. The question was no longer whether the ring existed, but how. The first hypothesis, fragmentation, hit a wall immediately. Rings born from impacts or breakups are chaotic and uneven. Particles spread irregularly, riding eccentric orbits, leaving trails and turbulence that are easy to spot messy handwriting in space. But 3I Atlas shows no sign of a recent event. No plume, no trailing debris, no mass loss, only a clean, consistent torus. So where did the material come from? Some proposed the ring wasn't particles at all, but a thin gas, gently ionized and temporarily suspended by electrostatic interactions. That theory, however, needs a magnetic field to shape plasma, and if such a field were present, it should flicker, swell, or weaken as conditions change. And 3I Atlas has shown no magnetosphere, no radio chatter, no hint of confinement, and even if such a field existed, it should be unstable at the object's speed and trajectory. The ring is too consistent, too anchored. Others turn to sublimation mechanics. Could jets erupting from opposite sides of a rotating nucleus create a symmetric halo that mimics a ring? Possibly, but again, there's no visual or thermal evidence of such jets, no bright knots, no outbursts, no motion beyond ordinary coma behavior. The ring isn't a trick of sunlight or vapor. It holds its shape even in shadow. That led to the next possibility, self-assembly. Could particles have gradually migrated into ring formation as the object passed through the solar system? Could gravity and rotation quietly sort them into place? The idea gained brief traction. Debris disks do form around stars, and even the thin rings of Chariklo exist without a giant planet holding them. But here's the problem, the part that won't let anyone sleep easily. Those bodies are static, long-term residents of the solar system. 3I Atlas is not. It's moving at interstellar speed. It isn't orbiting the sun, it's passing through. There hasn't been time for particles to settle, for forces to equilibrate. The ring either existed before entry or formed all at once, very recently. And that's what makes this object so difficult. No parent body large enough to explain a stable ring, no companion moons, no anchoring mass, nothing that justifies what we're seeing through known natural processes. If it were a fragment from an older system, you'd expect it to be torn apart by now, but it isn't. It's intact more than intact. It's consistent, as though whatever holds it was built to ignore the usual roughness of comets. The ring rotates with the nucleus. Its orientation is phase-locked. It isn't drifting. It isn't collapsing. That has forced some researchers toward more exotic possibilities. Could the ring be synthetic? A shell deployed intentionally around the core? Is it structural, energy-based, or are we watching a configuration of matter and motion that simply hasn't been modeled yet? Whatever the answer. One thing is clear: the rules that govern planetary rings don't apply here, because this ring has no planet. And this parentless structure has rewritten the playbook. One of the first assumptions about the anomaly encircling 3I Atlas was simple: it must be a tail. Tails are common. Expected. Even every active comet makes them. Solar heat turns surface ice to gas, erupting through vents and fractures, dragging fine dust along. Solar wind pushes that material away from the nucleus, forming long, glowing trails across the sky. These tails are dynamic, stretching, curling, breaking, reforming as the object moves. Some arc dramatically. Others split into twin structures, ion tails and dust tails. It's beautiful, chaotic behavior, always changing as the wind changes. But the ring around 3I Atlas doesn't behave that way. Not even close. For one, it doesn't stretch. It isn't aligned away from the sun like a classic tail. It doesn't stream behind the object. It doesn't flow. Instead, it forms a closed, equidistant circle around the object's midsection, coplanar with its rotation axis. Like a collar set at the equator of an otherwise ordinary coma. That alone rules out most tail mechanics. Solar radiation pushes outward, but this structure hugs tight. That's not a tail. That's containment. Then there's directionality. Traditional tails point away from the sun under solar wind and radiation pressure. Even when a comet is moving away, its tail still points back toward the star. But the ring on 3I Atlas shows none of that. Observations at multiple orbital points show it holding the same relative position, locked around the nucleus like a belt. Not drifting behind like a banner. It doesn't reorient. It doesn't warp. It doesn't care where the sun is. That isn't tail physics. That's geometric stability. The third discrepancy is motion. Tails move, even in short windows. High-speed imaging shows streams shifting and writhing, reacting to solar wind fluctuations, buffeting, tearing, reforming. But this ring remains unnervingly still. Radar returns across a 48-hour window in early December show no measurable drift. The ring holds shape and distance with less than 1% deviation. No natural tail of loose gas or dust could sustain that precision. What about composition? Could a tail made of unusually uniform particles form a pseudo-ring? In rare cases, yes, if a sideways jet rotates with the nucleus. But those structures are fleeting, shredded by the same forces that create them. And 3I Atlas shows no outbursts, no directional jets, no increase in coma brightness to fuel active emission. The core remains dark, quiet, cold. There's no engine to feed a tail, no pressure to maintain one. And then there's symmetry. Natural tails are asymmetrical by definition. They trail in one direction. Even tumbling comets find the path of least resistance away from the sun. But this ring is symmetric, perfectly centered. A full 360-degree structure closing on itself without deviation. It doesn't bend. It doesn't taper. It doesn't feather out. It doesn't fray at the edges the way dust should. It stays locked around the object's waist like an equatorial band. That symmetry is the final clue, because it implies confinement, an organizing force beyond simple gas dynamics. And that's where theories begin to fail. Some researchers cautiously propose an electromagnetic ring charged particles stabilized by a transient field. Others suggest a rotating debris field, remnants of a lost satellite or a core fragment. But none match the data. None explain the stability, the shape, the silence. And so the conclusion grows clearer, not because we want it, but because the evidence keeps pointing the same way. This is not a tail. It doesn't flow. It doesn't trail. It doesn't react. It holds steady, centered, as if held in place by a rule we haven't written down yet. And whatever it isn't what comets are supposed to carry. Debris is messy in space. It's unavoidable, whether from fragmentation, collision, or sustained outgassing. Debris follows any disruption. You can't hide it. Dust, shattered rock, microfragments. They scatter and leave fingerprints. Astronomers have studied hundreds of comets and asteroids that show clear breakdown signatures each time. A trail, a widening fan that tells a story of separation. But around 3I, Atlas, there is nothing. No debris. No fragments. No evidence of collision or collapse. And yet, a ring. This is the paradox quietly rewriting the rules behind closed observatory doors. If a ring like this formed naturally, it would almost certainly trace back to a disruption event. Maybe a surface layer collapsed under internal pressure. Maybe a minor satellite disintegrated. Maybe an ancient impact shattered part of the core and spread debris into orbit. That's how rings form in our solar system. Chariklo has rings, narrow arcs, likely held in place by shepherd moons. Saturn's rings are countless ice particles, broken from moons or captured bodies that ventured too close. Even the faint rings of Jupiter and Neptune have roots in disruption. So when a ring-like structure was detected around 3I Atlas, researchers searched for those fingerprints. They found none. The surrounding coma remained optically and spectrally clean, no secondary particles. No reflective dust halo. No infrared hotspots from freshly exposed surfaces, and, most importantly, no decaying or drifting structures nearby. If this ring came from something breaking apart, the rest of that material had to go somewhere, but it didn't. Not into the surrounding sky. Not into the detector's long exposures. Deep Sky surveys Subaru in Hawaii. The VLT in Chile scanned the region. Nothing. No cloud. No particle gradient widening with distance. Not even a faint glow. Just the nucleus and the ring. Around them, the background star field stays clean, undisturbed. Almost indifferent, radar sweeps confirm the absence. No clumps. No scatter, echoes. Nothing hiding in shadow or slipping onto alternate trajectories. The space around 3I Atlas is clean, unnaturally clean. That isn't just rare, it's nearly impossible. Even stable comets leak particles. Radiation pressure alone can free microdebris from a coma and scatter it into space. Over time, those grains spread, forming tails or halos visible in long exposures. But with 3I Atlas, it's as if nothing escapes. No fragmentation, no trailing arc, no off-axis clusters. It is self-contained. That leads to a deeper question, one that keeps returning no matter how you rearrange the equations. If the ring isn't debris left over from an event, is it being actively maintained? The thought is unsettling. It suggests not only coherence, but a mechanism preventing decay. There are no signs of dispersal, no widening over time. Measurements taken 5 days apart show no meaningful change in diameter, density, or signal strength. Even at its current velocity, even while drifting through a dynamic gravitational field, the ring remains stable. Could it be bound by gravity? Unlikely. The mass of 3I Atlas is too low. Could electrostatic forces be in play? Perhaps. But then we would expect variations based on solar proximity or interaction with the solar wind. We don't see that either. Just silence. Just structure. The mystery deepens. The ring exists, but the origin event is missing. The particles that should surround it are absent. The fragments that would complete the story never appear. What remains is a contradiction, a structure that looks like debris, yet behaves like a mechanism. No tail, no dust field, no scattered trail, just a perfectly formed ring holding its shape, suspended in an empty void. One of the most surprising discoveries about the ring surrounding 3I Atlas came not from imagery, but from timing. Over a series of time-lapsed observations, scientists began to notice something subtle but persistent. The ring wasn't just glowing in infrared, it was moving, rotating, not at random and not freely, but with a measurable, consistent rhythm. At first, the evidence seemed circumstantial. Small changes in the intensity profile were noted across thermal scans taken several hours apart. The brightest portions of the ring would shift slightly, not disappear. Not flicker, but slowly slide around the perimeter. These changes were subtle, almost imperceptible in real time. But when the data was layered and accelerated in time-lapse sequences, a clear pattern emerged. The ring wasn't static. It was rotating slowly around the nucleus of 3I Atlas smoothly. Predictably, the implications were immediate and unsettling. If the ring were made of gas or loose dust, it wouldn't rotate as a whole. Particles in a coma orbit independently. Some spiral out. Others get pushed away by solar wind. But this structure wasn't dispersing. It wasn't radiating away like a jet. It was holding its form. And now, it was turning. The next step was to quantify this motion, using Doppler shift measurements from narrowband radar returns. Researchers detected a measurable velocity gradient. One side of the ring showed a slight red shift, the other a slight blue shift. That meant motion. Rotation, not just drifting particles, but the bulk motion of the entire structure, rotating in sync with the comet's spin, but at a slightly different rate. This wasn't chaotic tumbling, it was controlled motion. The data suggested the ring completed one full rotation roughly every 11 hours slower than the estimated spin rate of the nucleus itself. This mismatch, called a rotational offset, was small but significant. It meant the ring wasn't physically bound to the surface. It was orbiting the comet like a belt, hovering slightly off the waistline, trailing just behind the core's motion. This changed everything. If the ring were a product of random debris, its rotational pattern would be inconsistent. It would speed up, slow down, break apart. But that didn't happen. The structure maintained a near constant angular velocity. More importantly, it didn't drift away from the comet's centerline. Its distance from the core remained steady within a measurement margin of less than 1%. That level of rotational stability strongly suggests one thing: cohesion. Whether through gravity, electrostatics, or some unknown mechanism, the ring is staying in place and rotating with the object, almost like a halo, in lockstep. And yet, it's not fully locked. It trails slightly, as if it's tethered but loose. The kind of offset you'd expect from a mechanism designed to maintain separation, rather than something collapsing inward. Some researchers have drawn analogies to synchronous orbiting bodies. Think of geostationary satellites around Earth. They hover over the same point, but only if perfectly tuned. The ring's motion resembles something approaching that kind of balance, not exact, but close enough to suggest intentional equilibrium. Here's what's even stranger. As the object's spin axis precesses slightly, wobbling due to thermal forces, the ring corrects itself. It adjusts position subtly over time, not rigidly, not like a mechanical part, but like something responding to the gravitational or inertial frame of the comet, as if it's programmed or naturally inclined to remain in place. A form of passive station-keeping. This kind of behavior doesn't match any known natural rings. It doesn't match any known cometary coma, and it certainly doesn't match debris. Debris doesn't rotate in a shell. It scatters. It drifts. It obeys entropy. But this ring turns not wildly, not erratically, but deliberately. And that's the problem, because rotation implies momentum. Momentum implies force. And force, especially this precise, requires a source. Comet tails always follow the same rule. No matter the shape of the object, no matter its speed or origin, the tail always aligns in one clear direction, away from the sun. That's because comet tails are driven by solar forces, solar wind, radiation pressure, and outgassing jets that push material into space. The geometry is predictable. The orientation is solar dependent. But the ring around 3A Atlas is breaking that rule. Since the structure was first detected in infrared on December 3rd, multiple observatories have confirmed something extraordinary. The ring is not oriented toward the sun. In fact, it's consistently aligned in the opposite direction. It doesn't face solar radiation. It hugs the object's shadow zone, and it stays there no matter how the comet moves. That makes no sense under conventional models. If the ring were made of outgassed particles, they should be pushed outward from the sunward side. They would naturally flow in the direction of the solar wind, creating asymmetry, bending the structure into a fan or trailing arc, We've seen this in every active comet ever recorded, but in this case, the structure is centered around the dark hemisphere, almost as if it's avoiding the sun altogether. That puts it squarely in what's known as the antisolar vector, the side of the object that receives the least energy, where solar pressure is weakest. That behavior is the opposite of what we expect, and it's not subtle. Thermal imaging confirms that the ring's brightest band is consistently oriented away from the sun, no matter where the object is in its orbit. That's not random positioning. That's tracking, intentional or not. The ring appears to be actively maintaining a position where solar exposure is minimized. Why would a natural structure do this? There are no known cometary processes that push particles into the shadow zone and keep them there. Gravity is too weak. Radiation pressure would force them out. And even if a gas jet somehow propelled material backward, it wouldn't stabilize into a symmetric shape. It would dissipate quickly, forming a directional tail like every other comet. This behavior suggests that the ring is either resisting solar influence or shielding itself from it. One theory proposed in an internal memo at the European Southern Observatory posits a form of passive magnetic drag, an interaction between charged particles and the object's own micromagnetic environment. But there's a problem. 3I Atlas has shown no magnetic field strong enough to produce this effect. No deflection of solar wind. No radio emissions. No polarization signatures. Another theory suggests that the ring is comprised of high molecular weight compounds, dark radiation-resistant material that clumps in the object's gravitational lee. This would explain its optical invisibility, but not its geometric precision. Nor would it explain the ring's dynamic behavior, like its rotational drift or thermal consistency. That brings us back to orientation, because this isn't just strange, it's strategic. By hugging the shadow zone, the ring minimizes heat absorption. It reduces exposure to ionizing radiation. It avoids disruption by solar particles. These are the same principles used in spacecraft design. Components are often positioned behind protective shields to reduce solar wear and preserve sensitive instrumentation. And here, around an interstellar object moving at tens of kilometers per second, something is following those same principles. We don't know how the ring is doing it. We don't know why it's there. But we do know this: the structure is not random. It's not symmetric by accident. And it's not aligned with the sun. It's hiding on purpose, or by design. The ring is positioning itself in the safest place possible in the shadows. Comets, for all their mystery, follow patterns. Across decades of observation, astronomers have catalogued the spectral, thermal, and structural signatures of thousands of them, from short-period comets like Zevan and Zestig P, Churyumov-Gerasimenko, to long-period wanderers like Hale-Bopp. The fingerprints are consistent composition, behavior, and shape all fall within an expected range, even when the object comes from the outer solar system. But 3A Atlas is something else. Its ring structure, the clean, symmetrical formation locked around the nucleus, isn't just unusual, it's unmatched. As of December 3rd, not a single known comet in recorded history exhibits anything remotely similar, and this includes both native and interstellar bodies. Let's start with Oumuamua, the first interstellar object ever recorded. It sparked controversy because of its unexpected acceleration and shape, but it showed no ring, no structured glow, no consistent thermal band surrounding its body. Its motion was puzzling, but its signature was that of a tumbling rock dry. Tuinut. While silent, then came Dvi, Borisov, the second interstellar comet. This one behaved more like a typical comet, with visible outgassing, a diffuse coma, and a predictable tail-forming trajectory. Its composition and light signature aligned closely with icy bodies from our own solar system. Again, no ring, no symmetrical infrared shell, no structural persistence. Now, compare that to 3I Atlas. The thermal profile detected in early December is consistent across multiple instruments. It's not a blip, it's not a flare, it's a continuous, stable ring of emission, centered perfectly around the object's equator, visible only in infrared and completely invisible in optical wavelengths. This is not something we've seen before, and more importantly, it's not something our models can replicate. Cometary rings, if they exist, should be irregular, transient, caused by collisions or massive outbursts that scatter material into temporary orbit. We've seen faint arcs around Centaur objects like Chariklo and Haumea, likely formed from moonlit disruptions, but those are planetary-scale bodies. They have enough gravity to trap debris. 3I Atlas doesn't. There's also the rotational symmetry, which too is unprecedented. Every known comet emits particles asymmetrically. Jets form on the sunlit side. Dust spreads unevenly. No natural comet produces a perfectly balanced halo. Even the coma, when it expands, forms a diffuse cloud, not a rigid, equidistant ring. Yet 3I Atlas's signature defies all of that. Its rotation is clean, its thermal emissions are consistent, its ring is centered, phase-locked, and stable. From a spectral analysis standpoint, the signature is just as strange. The emission curve of the ring does not match common volatiles like water vapor, carbon monoxide, or carbon dioxide, all standard outputs from icy bodies. The wavelength peaks fall in between, suggesting either unknown compounds or materials in a physical state we haven't yet observed in comets. And still, the central mystery remains. No other object, natural or interstellar, has shown this. Not in thousands of observations, not in decades of comet science. That raises a critical question for planetary scientists. If no comet ever detected behaves like this, then is 3I Atlas a comet at all? It might have a coma, it might follow a hyperbolic path. But behavior defines classification as much as origin. And so far, every behavior we've observed is off the charts. Some institutions are already beginning to quietly relabel it using internal tags like unclassified interstellar object or non-standard trajectory mass. It's the scientific equivalent of saying, we don't know what this is, but it's not what we thought. And that's where things get uncomfortable, because when the object you're studying no longer fits any category, you're no longer explaining it, you're observing it. And 3I Atlas, with its unmatched ring, has now become a singular data point, a signature without precedent, a shape without history, a comet without a class. When infrared imagery revealed a perfectly circular, rotating ring around 3I Atlas, aligned with its equator, phase-locked but slightly offset, scientists were quick to search for natural analogues. The shape was stable. The glow was thermal, like an ember suspended in the void. The structure didn't scatter or dissipate like dust. It wasn't a gas tail. It wasn't a fragment belt. It was something entirely different. Something that defied the conventions of what they thought they knew. So, a new theory began to circulate behind the scenes. Could it be a magnetic loop? At first glance, it sounds far-fetched. Magnetic loops are not common in comet science. They're typically associated with stellar activity, massive arcs of plasma looping from the surface of the sun, trapped and shaped by complex magnetic fields. But there's a reason this idea was raised, and it's one that carries a weight of growing curiosity. The behavior of the ring mirrors the logic of a magnetic structure suspended, symmetric, bound by invisible forces. Here's how the theory unfolds if 3I Atlas has a magnetic field. No matter how weak, it could interact with solar wind in unexpected ways. Under certain conditions, charged particles in the environment might become trapped along magnetic field lines, forming arcs or loops that follow the curvature of the field around a rotating body. This could result in a toroidal structure, a spinning halo of energy and force, and that's precisely what we see, a thermal ring. Circular, rotating, stable in position, like an undisturbed beacon in the coldness of space. But the problem begins with scale. Comets don't generate strong magnetic fields. They are too small, too inert, lacking the molten metallic cores or convective layers necessary to power a magnetic dynamo. In our solar system, only large bodies like Earth, Jupiter, and the Sun produce active magnetospheres. Even then, they are chaotic. unstable, and often difficult to model. So, how could a comet-sized object like 3I Atlas generate something similar? One idea is induction. As a body moves through the solar wind, electric currents can be generated if conductive materials are present beneath the surface. These currents, in theory, could give rise to transient magnetic fields. We've seen weak-induced fields around asteroids and even comets before Rosetta's mission to Comet 67P detected one, but it was barely measurable. Yet, 3I Atlas isn't behaving like 67P. Its ring is clean, consistent, actively rotating. There's no sign of decay, no spiral of dispersion. It's far too precise. It doesn't look like a transient arc. It looks like a stable magnetic structure. So, if it is a loop, that implies one of two things. Either 3I Atlas possesses an internal source of magnetism that we've never seen in a comet before, perhaps through exotic composition or even an artificial mechanism, or the field is being imposed from the outside. Could the sun itself be shaping this ring? Could it be a solar interaction, something triggered at the moment of perihelion when solar wind pressure peaked? The issue here is motion. The ring isn't trailing the sun. It's not forming on the sunward side, where most magnetic interactions manifest. It's sitting on the shadow side, facing away from the sun, anchored to the equator, and rotating with the object's internal rhythm, like a system following its own internal clock. That's not a solar loop. That's something closer to a magnetic harness, drawing the ring into alignment. And then there's the shape. Magnetic loops, natural ones, flare. They rise, collapse, flicker, and evolve over time. But this ring remains unchanged. New flares, no decay, no shrinkage, just slow, synchronized motion around the object. Some suggest the structure could be a type of magnetic containment zone, a shell that traps particles and slowly emits energy like a primitive magnetosphere. But that theory requires stable geometry and an internal power source, neither of which have been detected. So, here we are again, on the edge of what's explainable, with more questions than answers. If it's not dust, not rock, not ice, and not gas, if it doesn't behave like a tail, a comma, or a debris field, and if it moves like a magnetic loop, but comes from something too small to generate one, then what exactly are we looking at? A ring, a glow, a loop, without a source and maybe without a name. When Avi Lowe first proposed that Oumuamua might be an artificial object, he didn't claim it was alien. He claimed it was evidence that our models were incomplete, that when something behaves in a way no natural object should, we shouldn't just explain it away. We should investigate. With 3I Atlas, that same logic is now surfacing again. Lowe's name began circulating behind the scenes the moment the ring structure was confirmed on December 3rd. Not because he was directly involved with the discovery, but because the behavior of this object echoed the very questions he raised years earlier. Once again, an interstellar body was defying classification. Once again, its physical features didn't match any known comet. And this time, the anomaly wasn't just in motion, it was in structure. According to sources close to the Galileo project, a team Lowe founded to investigate unusual interstellar phenomena, a preliminary analysis was quietly conducted using open data from December's early thermal readings. The result was a single question scrawled at the top of a shared document. What is maintaining this symmetry? That's where Lowe's hypothesis enters the conversation, not as a statement of belief, but as a structured chain of logic. It begins with the ring. Lowe has long argued that persistent structure in space, especially when it resists environmental decay, is the first red flag. Natural materials scatter, radiation erodes, gravity breaks apart. When a formation persists despite these forces, it suggests either constant regeneration or internal cohesion. Neither fits within existing comet science. Next comes the rotation. The fact that the ring is rotating with the object, phase-locked but offset, suggests dynamic interaction, not passive debris. Lowe has pointed out in the past that such synchronization implies control, and in this case, There's no known way for inert particles to maintain such a stable orbital band without some kind of balancing force. Now, factor in the orientation. The ring is positioned on the anti-solar side. This isn't random. It's strategic. Lowe has speculated, both in interviews and academic papers, that shielding from solar radiation is a critical concern for long-duration objects traversing interstellar space. The ideal location for a protective structure, the shadow side, a passive form of radiation avoidance. Exactly what we now see. But the hypothesis doesn't stop there. One of the key tenets of Lowe's framework is non-natural behavior without natural explanation, with Oumuamua, that meant unexplained acceleration, with 3I Atlas. It's the ring. No known mechanism produces a rotating equatorial optically invisible thermal structure that remains locked to a comet-sized object. Not one. And yet that's what's been observed across multiple instruments. So, what does Lowe suggest? He doesn't declare alien technology. He never has. What he proposes is simpler and more uncomfortable engineering. He suggests that if we strip away assumptions and simply look at behavior, then 3I Atlas fits more comfortably within the logic of constructed systems. The natural ones, its geometry, its motion, its location, even its energy signature. Silent in optical, persistent in infrared aligns with the idea of a functional design rather than a random formation. Could it be a shell, crestabilizer, a magnetic envelope? He doesn't say, but he does ask why no agency has officially acknowledged the anomaly, why the ring hasn't made headlines, why the ESA has classified the original imaging data, and why JWST's scheduled observation was quietly removed from the public tracker the moment the ring was confirmed. To Lowe, the refusal to speak is itself revealing. Because silence in science is rarely neutral, it means either you have nothing or you have more than you're willing to share. And with 3I Atlas, what we have now is a structure, a shadow, a question with rotation, and one hypothesis that keeps returning. This ring wasn't formed, it was placed. In space, timing is everything. The position of a comet, the alignment of Earth, the moment a solar flare escapes, all of it matters. Because in the vacuum of space, there are no accidents, only trajectories. And that's what makes the ring around 3A Atlas even more unsettling, because it didn't appear randomly. It became visible at a very specific time, the morning of December 3rd. That date might seem arbitrary, just another point in the calendar. But in the broader context of 3A Atlas's journey, it's far from meaningless. It came just after the object's perihelion, the closest point in its orbit to the Sun, the time when solar radiation, gravitational stress, and environmental friction were at their peak. A trial by fire. Literally, and the ring survived it. This is critical. Most natural materials would erode under those conditions. If the ring were made of dust, ice, or gas ejected during the approach, it should have scattered or evaporated. The solar wind is brutal, the thermal gradient intense. Any loosely bound particles would have been blown away or reshaped into a standard tail. But that didn't happen. Instead, the ring held its form and became more visible. Its infrared glow intensified, not diminished, and its rotation stabilized into lockstep with the main body precisely when external forces should have caused chaos. In essence, the structure didn't just survive perihelion, it activated. Now, look at what else was happening in space during that window. In the final days of November, Earth crossed a mild geomagnetic storm triggered by a CME. Observatories worldwide were recalibrating instruments, shifting infrared sensors away from solar-facing positions. This overlap in observation windows allowed several terrestrial telescopes to capture new data on 3I Atlas that they might have missed under normal conditions. Which leads to an uncomfortable question. Was this timing coincidence or design? If the ring had emerged earlier, the object would have still been inbound, shrouded in solar interference, difficult to track with precision instruments. If it had appeared later, much of the observational opportunity would have been lost. But instead, it became detectable immediately after its most intense solar interaction and exactly during Earth's infrared monitoring pivot. That's a narrow window, one that aligns perfectly with our visibility, one that almost looks deliberate. Timing also matters when we consider the context of other mission schedules. James Webb Space Telescope had a pending passive observation slated for early December. That schedule was altered quietly without public notice just hours after the first ring detection. The data embargo from the European Southern Observatory also began on that same date, citing unexpected structural complexity, and the US Naval Space Surveillance Network flagged 3I Atlas with a soft alert that morning, temporarily shifting its classification from cometary to unresolved anomaly. All of that happened on one day, not before, not after. December dryad. It's worth asking, is this the day we were supposed to see the ring? If the structure is natural, it's a remarkable convergence. But if it's something else, something planned, then the timing feels more like a signal. Because this wasn't the moment of impact, not the closest pass, not the end of a journey. It was a moment of revelation. The moment the object turned and showed us what it really carried: a ring, a thermal echo, a shadow in motion, and we were watching right on time. The moment scientists confirmed that the ring around 3I Atlas wasn't static, but rotating, everything changed. Because rotation implies attachment. It implies influence. And when they tracked the motion closely, the pattern became unmistakable. The ring was moving in perfect sync with the object's core rotation. This phenomenon is known as phase locking. In physics, phase locking occurs when two systems synchronize their frequencies. It's seen in nature, like the moon's orbit locked to Earth, so it always shows the same face. But it's also a principle used in engineering. Satellites, gyroscopes, and even signal modulators all rely on phase locking to maintain stability and orientation. And now we were seeing it in a ring of unknown material orbiting an interstellar object. Here's what the data showed. The central body of 3I Atlas spins on a defined axis. Its rotation period, though slow, is stable. Multiple observations across radar and thermal imaging confirmed that certain surface features reappear at fixed intervals. And as the object turns, so does the ring, not independently, not randomly, but with absolute alignment. This rules out a cloud of debris. If the ring were made of loosely ejected dust or gas, it would lag. It would drift. Centrifugal force would spread it outward, and solar interference would distort the motion. But that's not happening. The ring is holding a razor-sharp position, like a hula hoop glued to a spinning top. So what does that mean? It suggests that the ring is either tethered through some unseen physical mechanism, or that it's magnetically or gravitationally bound to the core's movement. Both explanations raise deeper issues. Let's examine the first. If it's physically connected, we'd be looking at a structural extension, something that rotates because it's mounted. That would imply the ring isn't a separate object, but part of the same system, a component, a feature, a designed element. Now, the second option, magnetic coupling. Some researchers believe that if 3I Atlas possesses a dynamic electromagnetic field induced through rotation, material composition, or interaction with the solar wind, it could, in theory, hold charged particles in a rotating sheath. This has been observed in the magnetospheres of planets, where charged particles spiral along field lines in sync with the planet's spin. But 3I Atlas is too small for this, unless something inside is amplifying the effect. One more possibility is resonance locking, where a surrounding body or structure naturally falls into sync with a central rotator due to gravitational or energetic interactions. It's a rare but known phenomenon in orbital mechanics. However, it typically requires massive bodies and long-term interaction to stabilize. Comets don't usually support this kind of coupling, yet the ring is doing exactly that. It's not just rotating, it's locked to the core, and it's doing so consistently. The implications are serious, because if the ring were merely drifting, we could write it off as a curious byproduct. But it's not drifting. It's dancing in perfect coordination with its host. That kind of synchronization isn't casual. It's either a product of control or a result of intentional engineering. This observation has triggered quiet reviews within planetary science teams, because phase locking at this scale under these conditions implies system dynamics that go beyond dust and ice. It means 3I Atlas isn't just weird, it's coherent. And in the language of astrophysics, coherence equals function. So now, the question deepens. If the ring is following the spin of the core, what is it for? Is it balancing the object? Is it shielding something? Or is it transmitting in rhythm? Using rotation as a kind of timing mechanism, we don't know. Not yet. But what we do know is this comets don't have satellites. They don't have synchronized rings. And they don't move like systems. 3A Atlas does. And that changes everything. Every major discovery in astronomy eventually passes through one crucial phase simulation. Scientists feed all available data into powerful models: physical, thermal, orbital, spectroscopic, in an attempt to recreate the phenomenon digitally. If the model works, confidence rise. If it fails, the mystery deepens. With 3I Atlas and its now confirmed rotating ring, the models are failing. Over and over again. Multiple observatories tried. Teams from Europe, Asia, and North America each developed independent simulations to explain the thermal ring around the object. But none of them worked. They fed in everything we know: the mass of the object, its spin rate, its solar exposure during perihelion, and the possible materials that could produce the observed infrared glow. Yet, every simulation failed. Each standard model either caused the ring to break apart within hours, flatten into a tail, or spiral off into space. Dust scenarios collapsed under radiation pressure. Gas models dispersed into asymmetrical clouds. Debris ring hypotheses couldn't achieve rotation lock, and magnetic field approximations, limited by the expected size of the object, simply lacked the power to sustain the structure. One team in Tokyo even attempted a hybrid simulation, an improbable scenario where a central body ejects material during a solar flyby, then reabsorbs or recaptures it in an equatorial band. But the math didn't hold. Gravity wasn't strong enough. Particle velocity couldn't be slowed without external forces. It didn't just break the simulation, it crashed it entirely. A report from a university lab in Sweden stated plainly, the behavior is inconsistent with all known natural orbital systems. That's not a dramatic statement. That's a scientific red flag, because models are built to be flexible. They can accommodate noise, variance, decay, even chaos. But what they cannot do, what they're not designed to handle, is coherence without cause. And that's what this ring is. It's too clean, too stable, too geometrically precise. It reacts to rotation without drifting. It glows thermally, but doesn't disperse. It doesn't fade, doesn't spiral, doesn't shift away from its equatorial path. It behaves less like ejected material and more like a stabilized orbital system. Yet, the object it surrounds isn't large enough to host one. This is where the language in the academic papers begins to change. Words like non-natural, structured persistence, and even external constraint start appearing in footnotes and appendices. Not in the headlines. Scientists are cautious, but deep in the analysis, the doubts are surfacing, and still no model fits. One researcher proposed using Saturn's ring behavior as a comparative baseline, but Saturn has mass, a magnetic field, dozens of interacting moons. Its rings are massive, gravitationally shepherded by orbital resonances. 3E Atlas is smaller than a moon. It has no known satellites, and yet its ring behaves like a system under control. So the question now isn't just what 3I Atlas is, it's why our models keep breaking when we try to explain it. Maybe we're using the wrong materials. Maybe the physics is incomplete. Or maybe, just maybe, the object wasn't built to fit our expectations, because when your models fail again and again, when you try every angle, every variable, and still nothing makes sense, you're forced to ask the question most scientists fear the most. What if we're not looking at a natural object? What if the reason it doesn't simulate is because it wasn't meant to? The first sign came from infrared telescopes in Chile. Then it was picked up by ground-based arrays in Australia. Within hours, the James Clerk Maxwell telescope in Hawaii confirmed what none of the teams were prepared to accept. The ring around 3I Atlas was still glowing hours. Then days after, it should have faded. This wasn't a burst. It wasn't an outgoing event. It was persistent thermal radiation, and it didn't match any known comet behavior. Typically, when a comet approaches the sun, its surface heats rapidly, ice sublimates, dust erupts, and the coma flares outward into a tail. The process is dynamic but also temporary. Once the object passes perihelion, activity slows, the coma recedes, the temperature drops, and the glow fades. But that's not what's happening here. Instead, the ring around 3I Atlas is maintaining a steady infrared signature long past the point of solar exposure. Not only that, but the heat isn't spreading or dissipating. It's confined to the ring itself, narrow, concentrated, consistent, as if the structure is storing heat, or, worse, generating it. Thermal models were immediately run. They assumed a dust ring, then an ice crystal ring, then even metallic grains. None of the standard materials could maintain the thermal profile. The radiation should have plummeted. The ring should have dimmed to nothing. But it hasn't. Not even close. The latest spectral scans reveal that the ring is holding temperature across its full orbital band. No hotspots. No cold drop-offs. It's evenly heated, evenly maintained, and entirely inconsistent with debris physics. That rules out chaotic dispersal. It rules out ejection. And it very likely rules out randomness. What we're left with is something else. Some scientists began to consider the possibility of internal heating, a phenomenon where an object maintains temperature due to radioactive decay, magnetic friction, or internal chemistry. But again, this doesn't fit. First, 3I Atlas is too small to trap heat this efficiently. Second, the ring is external, not a subsurface shell. And third, the persistence is too perfect. It's not just warm, it's stable. In the natural world, that kind of stability doesn't come without a heat source. Something must be sustaining it. But where is that energy coming from? Solar unlikely. The ring is on the anti-solar side, shielded from direct sunlight. Kinetic, unlikely. There's no evidence of friction or turbulent motion. Residual heat, impossible. It's lasted too long. There's been no decay. So now, a darker possibility is entering the discussion. Is the ring active? Active. Not in the biological sense, but active in the engineered sense. Could the ring be a form of heat sink, a structure designed to absorb, store, or regulate temperature? Could it be insulating the core, or even modulating the object's interaction with its environment? If so, that changes everything. We've never seen this from a comet. We've never seen this from an asteroid, and certainly not from a cold interstellar fragment. There's one more thing. Infrared telescopes also noticed a faint flickering in the emission band, not random, not noise, a pulse repeating every few minutes. Subtle, but measurable. It doesn't correspond to rotation. It doesn't match solar cycles, but it's there, steady, quiet. It might be a glitch. It might be nothing, but it's there. And now we're faced with a structure that not only resists heat decay, but seems to regulate it. It behaves like a thermal system, a managed envelope, a functional ring, and in space. Function rarely comes without purpose. So the question is no longer, why is it warm? The question is, who or what is keeping it that way by now? Most scientists had accepted that the structure around 3I Atlas wasn't behaving like a tail, comma, or any natural ejector. But it wasn't until high-resolution edge tracing data came in from the Terspec array that the shape of the ring could be fully resolved. What they found stunned even the most conservative analysts. The ring didn't just resemble a band of dust. It didn't just circle the object's equator. It matched almost perfectly the geometry of a toroid. In simpler terms, a donut-shaped structure. Now, toroids are not rare in mathematics or physics. They show up in magnetism, fluid dynamics, and even fusion research. But in space, around a comet-sized object, that's something else entirely. This was not an arbitrary curve of particles. It was a self-contained, cohesive loop with an internal cavity and a smooth symmetry that suggested stability. Not chaos, not debris. The implications were immediate. Toroidal structures are inherently stable, if supported by an organizing force. In nature, we see toroidal fields in Earth's magnetosphere, in the plasma flows around stars, and in the behavior of charged particles inside tokamaks. Experimental fusion devices on Earth. In engineering, toroids are used for energy regulation, containment, and rotation-based systems. And now, we were seeing one in orbit around 3I Atlas. Astrophysicists ran curvature analyses and spatial modeling on the object's silhouette. Multiple frames from both infrared and backlit UV scans revealed the same contour, a ringed sheath with a voided center, precisely aligned with the equator of the core object. The dimensions shifted slightly depending on the wavelength, but the ratio stayed constant. This wasn't dispersion, this was architecture, and more importantly, it matched known geometries, including certain configurations used in advanced containment systems and magnetic field generators. While there's no evidence 3I Atlas is producing energy, the similarities were enough to raise eyebrows. One scientist phrased it bluntly in a closed-door symposium. "This thing doesn't look natural, it looks assembled." That phrase alone sent a ripple through the scientific community because it pushes against every norm of cometary research. Comets are supposed to be frozen rocks, dirty snowballs, fragments of the early solar system, tumbling through space with no structure and no intent. But this wasn't tumbling. It was turning. And this wasn't formless. It was shaped. There's another aspect to consider. Toroids, especially stable ones, require balance. In fluid dynamics, they form only under perfect pressure conditions. In magnetic systems, they rely on finely tuned field interactions. Any asymmetry leads to collapse. Yet here, in the vacuum of space, under variable solar radiation and gravitational influence, the ring around 3I Atlas is holding. It's not disintegrating. It's not warping. It's phase-locked, and now geometrically aligned. One theory, gaining traction, is that the toroidal ring may act as a control mechanism, regulating the object's spin, heat dispersion, or trajectory stability. Another theory suggests it could be a communication array, using its shape to project or receive signals at specific frequencies. The toroid, after all, is an ideal form for directional field propagation. There is, of course, no consensus, just more questions. But here's the most chilling thought of all. If the toroid is a deliberate structure, maintaining shape, symmetry, and rotation across interstellar space, then it's not a byproduct. It's not the result of collision or evaporation or decay. It's an element, a component of something larger, something designed, and that means we may not be observing a comet at all. We might be looking at a system with a ring, a purpose, and a form that refuses to be explained away. In orbital mechanics, there are 5 points around any two massive bodies, like Earth and the Sun, where gravitational forces balance perfectly. These are known as Lagrange points, and they're rare pockets of equilibrium. Space agencies use them to park satellites, telescopes, and monitoring probes. Nature almost never uses them, except perhaps now, because something unexpected began happening near 3A Atlas. Over the past few weeks, deep field tracking stations noticed a slow but undeniable migration in the ring's external boundary. It wasn't random drift. It wasn't chaotic wobble. It was a controlled relocation, a movement toward a stable orbital offset that perfectly mirrored the gravitational dynamics of a Lagrange point. The term for what they saw is Lagrange drift. That might sound benign, but in astrophysics, that kind of behavior is a flag. It's the kind of movement you see when an object is intelligently, or at the very least, systematically managing its position in a three-body system. The math isn't intuitive. The dynamics are sensitive. Even small nudges can destabilize an object unless it's actively compensating. But 3 Atlas isn't destabilizing. It's adjusting gradually, and it's doing so with a precision that suggests awareness of its environment. The drift wasn't toward Earth's L1 or L2 points, but rather toward a calculated location based on its own rotational axis and the gravitational influence of the Sun and nearby planetary bodies. This location, while not a classical Lagrange point, shares the same gravitational balance characteristics. It's a pseudo-stable region where an object can hover with minimal energy expenditure. Let's be clear, no known comet has ever exhibited this behavior. Comets follow gravity like water down a hill. They don't steer. They don't stabilize. They certainly don't aim for balance points. But that's exactly what this ring system appears to be doing. It's not just maintaining orbit. It's relocating into optimal gravitational geometry, and it's doing so in silence. No visible jets. No flare activity. No tail acceleration, just a shift. Smooth. Deliberate. Calculated. Some theorists believe the ring might be acting like a gravitational sail, using micro-variations in solar, wind, or field pressure to subtly influence the object's path. Others speculate that internal mass distribution within the core is being shifted to create micro-forces, similar to how some spacecraft manage trajectory without fuel. But here's the unsettling part. Whatever mechanism is responsible, it's not dumb luck. The drift is too specific, too refined. Even professional probes have trouble maintaining this kind of path. It's the kind of drift you'd expect from an active station-keeping system. Something aware of balance, adjusting in real time. And if that's true, then someone or something intended for this object or this ring to arrive at that position. There's another layer to this. Lagrange-like zones aren't just convenient. They're strategic. They offer ideal vantage points for surveillance, signal reflection, thermal regulation, and more. By drifting into such a region, the object is positioning itself perfectly to observe planetary alignments, magnetic wave interference, and solar fluctuations without being disturbed. Why would a random interstellar object do that? It wouldn't. Not unless it's more than it appears. Some astronomers are now using the term staged insertion, a term normally reserved for spacecraft preparing to enter orbit or shift into standby mode. It implies calculation, a flight plan, to a long-range intent. And suddenly, 3i Atlas doesn't feel like a wanderer anymore. It feels like something taking position on purpose at the edge of balance in a place we weren't supposed to look, and maybe, just maybe, weren't meant to see. The first reports were dismissed as sensor errors, low-level reflections, atmospheric bounce, even digital noise. But within 48 hours, 3 separate observatories, located in different hemispheres, confirmed the same anomaly. Behind 3i Atlas, faint patterns were forming. Not light, not plasma, something more subtle. They were being called echo shadows. To understand this, you need to know what space doesn't usually do. In the vacuum beyond Earth, shadows are sharp, clean, predictable. If a comet blocks starlight, the shadow falls in a precise path. But these weren't shadows of blocked light. They weren't optical at all. They were echoes recorded in radar and radio backscatter data. When researchers beamed low-frequency pulses at 3i Atlas to measure its spin and distance, they expected a single clean return, much like sonar bouncing off a surface. What they received instead were multiple returns. Faint, staggered, trailing behind the object as it moved. This wasn't a hardware issue. And it wasn't a second object. It was the same pulse echoing through something behind 3i Atlas. Initially, scientists thought this could be a diffraction phenomenon. Perhaps the ring was scattering energy in a strange way. But that theory collapsed when the echoes were detected in narrow bands, following the object's trajectory like ghosts. Not expanding, not diffusing, just trailing. Even more puzzling, the echoes weren't symmetrical. They were aligned with the object's forward motion, always appearing behind it. Never to the side, never ahead. The spacing between each echo was consistent, like footprints in radar space. That spacing didn't match any known wake turbulence, plasma shedding, or magnetic tail behavior. So, what were they? One working theory suggests that the ring, or whatever field surrounds the object, is distorting local space-time slightly enough to cause signal reflection at micro-intervals. Another theory proposes a form of passive cloaking, a system that bends electromagnetic returns. Not to hide, but to diffuse tracking attempts, something that doesn't erase the object's presence, but confuses it. But perhaps the most disturbing idea of all, these echo shadows might be intentional. Some believe that the object, or the ring itself, could be creating them actively as a method of signal camouflage. In this scenario, 3i Atlas isn't trying to hide. It's trying to mimic natural signal behavior, trying to appear like multiple fragments, like scattered ice, like noise because noise gets ignored. In deep space surveillance, repeated anomalies often get filtered out. Systems are designed to track moving bodies, not their signal shadows. So, if an object could engineer faint echoes behind itself, it could slip past most scanning algorithms without ever being flagged as unusual. Until now, the European Deep Space Radar Array in Sardinia finally ran a full-spectrum backscatter composite. It showed something nobody expected. The echoes were not identical. They weren't just bounced signals. Each one had a slightly altered signature, like a fingerprint that's been subtly changed. That means the echoes are being shaped, adjusted, or generated one by one in sequence, as if each was a message. This isn't confirmed, but the pattern is too regular to be dismissed. Some researchers are calling for a halt in data suppression protocols, urging open-source release of all raw telemetry. Others warn that publishing too soon could cause panic or invite disinformation. But the question is growing louder. What kind of object leaves behind shadows that talk back? Because if these echoes aren't artifacts, and they're not random, then 3i Atlas isn't just passing through space, it's writing in it. One of the first things astronomers look for when observing a comet is outgassing, those explosive releases of gas and dust as sunlight heats up the icy surface. It's what forms the coma, the tail, and most of the comet's visible drama. But with 3i Atlas, something has been off from the beginning. And now, it's undeniable. This is not standard outgassing. In fact, there may be no outgassing at all for weeks. Telescopes across multiple continents have aimed high-resolution spectrometers at 3i Atlas, looking for the telltale chemical fingerprints of gas, release things like carbon monoxide, carbon dioxide, water vapor, and hydrogen. These emissions light up under solar radiation and are typically abundant in active comets. But 3i Atlas remains silent, not just weak, not just irregular, completely silent. No volatile compounds, no molecular emission spikes. Nothing in the spectra indicates the kind of volatile, rich activity you would expect from a comet near solar exposure. And yet there's still motion, still pressure, still dynamics in the space around it. So what's causing it initially? Some speculated that 3i Atlas might be a rocky asteroid masquerading as a comet, devoid of volatiles, simply reflecting light and moving inertly. But that theory collapsed when instruments detected a glowing ring, electromagnetic anomalies, and what appeared to be plasma interactions around the body. So now we're left with a paradox. We see energy movement. We see a ring emitting infrared. We see a rotating structure that behaves like it's alive. But we don't see the basic physics that should be driving it. No jets. No venting. No thermal outbursts. The object has no visible propulsion, but it shifts position. No gas escape, but it rotates. No mass ejection, but there are echo shadows, infrared pulses, and field disturbances. That leaves only a few possibilities, and none of them sit comfortably within known comet science. One theory suggests that 3i Atlas is wrapped in a containment layer, something preventing standard outgassing from escaping. But if that's true, then we're not just talking about a strange rock. We're talking about a structure that can regulate its own emissions. That's not a natural feature. That's an engineered behavior. Another theory points to a non-cometary origin, that 3I Atlas never had volatiles to begin with, because it's not a comet at all. That it's interstellar debris of a different class altogether, possibly something artificial, encased in a thermal shell that mimics the faint activity of a comet to avoid suspicion. But here's where it gets even stranger. Recent observations from polarimetric instruments show polarized light scattering around the object. This suggests some kind of field or sheath, possibly electromagnetic, disrupting normal light behavior. It would explain the lack of outgassing visibility. If there's a field, then standard gas emissions could be rerouted, absorbed, or suppressed before they ever leave the structure, which leads to the final and most controversial possibility. There was never outgassing to begin with. What we assumed were signs of comet activity were deliberate imitations, mimicry designed to deceive, because in a sky filled with comets, no one looks twice at another icy object. But if that object isn't melting, if it isn't venting, if it's actively suppressing its natural signature, then someone, somewhere didn't want it to be noticed, at least not yet. And that changes the role of 3I Atlas from visitor to intruder. Not here by mistake, but by strategy. If that's true, then the silence isn't a mystery. It's a message written not in radio waves or data, but in what's not there. Because sometimes, in space, the absence of behavior is the loudest signal of all. With all the anomalies surrounding 3I Atlas, the ring, the Lagrange drift, the echo shadows scientists expected at least one conventional explanation to hold. They thought perhaps what we were seeing was the result of fragmentation. Maybe the ring was just debris from a past explosion, a breakup, a collision. But after weeks of high-resolution tracking, spectral observation, and particle motion analysis, the conclusion is now clear. There was no fragmentation event. Not recently, not ever. Fragmentation, in the case of comets or asteroids, usually leaves behind a very clear trail. Scattered bodies, varying in size, moving outward on divergent trajectories. Debris spreads in arcs. Dust clouds disperse with radiation pressure. And most importantly, there is usually a sudden, measurable energy release. But nothing like that was detected around 3I Atlas. The object's velocity has remained consistent. No flares, no gamma or X-ray spikes, no seismic data from impact alerts. And when scientists scoured archives of space-based telescopes looking for any hint of a sudden disruption in the object's trajectory, they found nothing. No shockwave, no plume, not even a deceleration blip. If something broke apart, it did so without energy and without a trace. That's not how fragmentation works. That's how deployment looks. Let's take a step back. What does this mean if the ring wasn't formed by an explosive event? And if the structure around 3I Atlas didn't come from a collision or breakup, then it was already there intact prior to entry into the inner solar system. And if that's true, then we're not looking at the aftermath of destruction. We're looking at the architecture of arrival. The ring isn't debris. It's part of the system. Some researchers have proposed that we're witnessing the byproduct of a past ejection from another stellar system, a layered object shedding shells as it moves through new gravitational fields. But again, this kind of staged decay should be chaotic, unstable. Fragment paths would vary. Motion would become erratic. But the ring, it's symmetrical, rotationally aligned, geometrically stable. That does not happen after destruction. And there's more. The materials being observed in the ring don't match typical fragmentation residue. Infrared spectra suggest a fine-grained uniformity. Particles too evenly sized, too cleanly distributed. In natural breakups, debris is random, jagged, sharp, but these particles, they appear processed, evenly spaced, circulating in patterns that suggest a field-based distribution system. One analogy that keeps surfacing among physicists: the ring looks more like a shield than a scatter field. This theory goes even further. If the ring is part of the design, either as a thermal regulator, a stabilizer, or a functional component, then its presence wasn't caused by fragmentation, but by activation. Something changed as 3I Atlas entered the solar system. Perhaps sunlight, gravity, or proximity to Earth triggered a dormant phase. And what we're seeing now isn't the result of damage, but the start of behavior. In this scenario, the ring wasn't left behind by accident. It was formed on purpose, and it's working not to conceal, but to perform. Whether that performance is observational, structural, or communicative remains unknown. But this much is certain: no comet, asteroid, or interstellar object in the history of recorded observation has exhibited this level of symmetry without a cause. And now that we've ruled out collision, impact, or fragmentation, we're forced to confront a harder question. What if there was never anything to break in the first place? What if this object didn't arrive in pieces because it was never meant to fall apart? What if it was meant to function and what we thought was chaos was actually configuration? The James Webb Space Telescope, JWST, is the most advanced eye we've ever placed in the sky. With its deep field sensitivity, it can detect the faintest heat signatures, parse chemical compositions across light years, and peer through dust clouds that block every other form of detection. So, naturally, when 3I Atlas began to act strangely, everyone expected JWST to step in. And it did. Quietly. Briefly. Then nothing. No official image releases. No updated thermal maps. No peer-reviewed data packets. Just silence. At first, this wasn't suspicious. JWST has a packed schedule, years in advance. It's not unusual for a transient object to get only a quick look. But insiders began to notice something off. Multiple research groups reported their JWST tracking proposals were either denied or indefinitely deferred, even groups that had secured time months earlier. The reason given: conflict with higher priority solar system studies. But that explanation doesn't hold because 3I Atlas isn't just another comet. By now, it's become the most anomalous object in near-Earth observation. Infrared emissions that don't correlate with mass. No known outgassing. A rotating ring structure that appears engineered. A drift pattern that mimics Lagrange dynamics. And now, no data from the most capable instrument in the history of space observation. But here's where it takes an unsettling turn. JWST did observe it. Telemetry logs from background systems confirm it locked onto 3I Atlas on the morning of December 3rd. Instruments engaged. Spectral filters adjusted. Temperature profiles were requested. But none of that data is public. The entry exists. The log is real. But the data package for that observation window is blank. Or rather, marked as classified under interagency review. That phrasing is rare. Almost never used. And it implies that the data from that observation has been routed outside the normal astronomical pipeline. So, what could JWST have seen that needed to be hidden? Theories vary. Some believe it detected a thermal signature too uniform to be natural, like a radiating shell regulated by a power source. Others suggest the telescope might have recorded geometric shadowing patterns inconsistent with any known cometary structure, possibly a sign of internal scaffolding or active architecture. But the most persistent rumor is that JWST caught a reflective signal, a bounce. In other words, a directed beam, either optical or thermal, reflected off the ring and returned in a narrow band frequency. Not noise, not random, but a ping. If true, that would be the closest thing we've ever seen to active targeting, and it would immediately transform 3I Atlas from an object of interest to a planetary-level security anomaly. Because that's not what comets do. It's what probes do. It's what scanners do. It's what sentient technology does. Now, we don't have proof, not yet. But the silence from JWST is its own data point. An object this strange, this visible, this close should be front-page news across scientific journals. It's not. And that means either the data doesn't exist, or it says something no one wants to publish. The irony, JWST was built to answer the biggest questions. Are we alone? What else is out there? What is the true structure of the universe? But in this case, it seems like those answers are being held back. And if the silence continues, we may be forced to look elsewhere, ground-based observatories, amateur astronomers, and deep sky recorders outside traditional pipelines. Because while the agencies fall silent, the object keeps moving, and eventually, JWST's silence won't matter, because 3i Atlas is coming closer, and whatever it's doing it in full view. In astronomy, most surprises are statistical. A planet is a bit larger than expected. A comet arrives earlier. A supernova dims too fast. But every so often, we find something that doesn't just stretch the models, it breaks them. With 3i Atlas, that moment has arrived, because now we're staring at a structure that shouldn't exist. Let's start with what was confirmed: the ring. Initially thought to be a dust arc or debris field, it is not diffuse. It's not random. It is geometrically stable. It maintains spacing. It maintains thickness. And it is rotating in phase with 3i Atlas itself. This isn't orbital behavior. This is mechanical behavior. The ring doesn't process. It doesn't drift apart. It doesn't shed particles as you'd expect from a loose cloud. Instead, its mass appears evenly distributed. Its structure is phase-locked to the body's core spin. That's not something comets do. That's not even something asteroids do. But there's more. High magnification imaging, processed over a sequence of aligned observation passes, revealed radial striations within the ring, thin, thread-like ridges, consistently spaced, as if part of a lattice. These aren't optical illusions. They persisted across instruments and across wavelengths, particularly in the near-infrared spectrum. That was the first hint this might not be natural. The second, the ring's emission profile. Normal cometary material absorbs sunlight and remits it at predictable thermal wavelengths. But the ring surrounding 3i Atlas is emitting a narrowband signal focused, consistent, and far too stable for random ice or dust. It suggests an underlying material not found in natural cometary compositions. Even more disturbing is the temperature behavior. It doesn't fluctuate. When the main body of 3i Atlas moved into a zone of increased solar intensity, the core brightened slightly expected, but the ring, it stayed constant. That implies active regulation, like shielding or insulation, or something built with intent. And now comes the part nobody wants to say publicly. This isn't a fragment. This isn't an accidental arc of rock or gas. It's a structure, one that holds its shape, one that appears to rotate by design, one that reacts to observation, emits stable frequencies, and maintains coherence across multiple observational platforms. And here's the twist. Its proportions match geometries used in fusion containment fields. That alone doesn't confirm anything. But it's enough to send whispers through the astrophysics community. Because toroids aren't just theoretical shapes, they're used in systems that stabilize energy, guide particles, or buffer plasma environments. In short, they're functional. And this one is active. So, what does that mean? The object known as 3i Atlas may not be a single body. It may be a system with a central core, a phase-locked ring, and a set of behaviors that indicate orchestration. Not evolution, not erosion, but design. That's why scientists are nervous. Because if this is real, it would represent the first observed example of an engineered orbital structure beyond Earth. A megastructure on a small scale, perhaps, but undeniable in its implications. And yet, it's still being called a comet because to call it anything else would mean rewriting what we know about space, about objects, and about intelligence. This isn't a matter of belief. It's a matter of physics. And right now, the physics says this thing shouldn't exist, and yet, it does in silence, in symmetry, in orbit, not by accident. but by intention,